Okay, hey everybody. I wanted to go through a couple of examples that I went through with class 1-1 yesterday, just so you don't miss out. So we're going to go through examples of two different skills that you'll need on the exam. And the first one is calculating pH. Now, three super important things you need to know about calculating pH. The first one is this formula, pH equals minus the log of the concentration of H plus ions. Okay, remember those square brackets there? Square brackets here, our concentration. Okay, and the opposite of pH is pOH. So we have a calculation, like a formula for that as well. So pOH is minus the log of the concentration of OH minus ions, hydroxide ions. Now, I will give both of these formulas to you on the day of the exam. So you don't have to memorize them, but you do need to know how to use them. The third piece of information that you need to know is that pH plus pOH equals 14. And this part you do need to memorize. So one way to remember this is to think about the pH scale goes from 0 to 14. So that's where we get this number here from. Alrighty, so I'm going to lift this up a little bit. Whoop. Now we have some more information. We also need to know that strong acids and bases fully dissociate in water. Now, what does this mean? Okay, I've got a couple of equations here for you. So hydrochloric acid becomes H plus ions and Cl minus ions. So fully dissociate means that everything on this side of our reaction changes to become our products. So every molecule of HCl becomes a H plus ion and a Cl minus ion. And from this, we can tell that our hydrochloric acid concentration is the same as our H plus concentration. This is super important because, remember, we need the concentration of H plus to find our pH. So, because we know this, if I give you the concentration of hydrochloric acid, then you can find out the pH using this relationship. But Ms. Griffith, you might say, what if it is a base? Well, here's an example of a base. So we got NaOH, sodium hydroxide. Now remember, if you see a metal and OH, that means you've got a base there. So NaOH becomes Na plus ions and OH minus ions. So we can look at this relationship. The concentration of sodium hydroxide equals the concentration of OH minus ions. And from here, we can use this relationship to find pOH. All right, so that's our example for a base. Now, little bonus for you as well. This is super important. What if we have an acid like H2SO4, sulfuric acid? H2 means that we have two hydrogens that can become H plus ions. So here we've got this coefficient of 2 out here. So this means our relationship is a little bit different because the mole ratio is a little bit different. So I've put the mole ratio underneath here. So we've got H2SO4 over 1 is equal to H plus over 2. Now if I rearrange that, if I know the concentration of H2SO4, I can have H2SO4 times 2 equals the concentration of H plus. All right, there we go. Okie dokie. Oof, that one's out of the way. Alrighty, so let's look at some examples. Let me get this in the right spot. Okay, example number 1, we have calculate the pH of 1.2 times 10 to the negative 4 moles per liter HCl. If we go down, remember from our relationship up here, the concentration of our acid equals the concentration of H plus. And we know this from the question is 1.2 times 10 to the power of negative 4 moles per liter. Now, remember, whenever you see moles per liter, this always means concentration. So we can use our formula, pH equals minus the log of the concentration of H plus. we put in our information from the question, our concentration, and put that in the calculator. Now, it's 3.9208. We got lots of numbers here, but our final answer should just be 3.9. Okay, we've got two significant figures here because the number from our question also has two significant figures. All right, move that one out of the way. You might say, Miss Griffith, what do I do if there is a base? Let's look at a question with a base. Here's example number 2. The question says calculate the pH of 3.4 times 10 to the power of negative 5 moles per liter NaOH. So remember, metal plus OH, this has got to be a base. All right, so again, we've got our relationship here. The concentration of NaOH equals the concentration of OH minus ions. And from the question, that is 3.4 times 10 to the power of negative 5. So now we can use our other formula to find POH. So POH equals minus the log of concentration of OH minus ions minus the log of 3.4 times 10 to the power of negative 5. And we come out with this huge number here, 4.468521083. So many numbers. Remember, we'll be dealing with our significant figures at the end. All right, so okay, we've got an extra step for bases, and that's using this relationship here. So remember, you need to memorize this relationship, and it is pH plus POH equals 14. So we know the POH from before. We calculated this. So here is the rearranging. pH equals 14 minus POH. So 14 minus 4.468599999. And our answer to two significant figures is 9.5. And that makes sense because this number is bigger than 7, and we know we started with a base. Now, a really important point here, important note, use your calculator for log calculations. This is so important, guys. I do not expect you to do log calculations in your head. Please use your calculator. Okay, our second topic today is dilutions. Okay, so let's have a little look at what is happening here. The stick is too sticky. All right, what is a dilution? Oh no, my paper. Okay, a dilution is adding water to a solution to make the concentration smaller. Super important. So our concentration is going to get smaller. Now, what do you need to know for this? Well, we need this triangle. This is our relationship for concentration. And we're going to put it in this arrangement. Number of moles equals concentration times volume. Super important. Now, in our lab, we saw this equipment, a volumetric flask, okay, and we added 25 mils, for this example, 25 mils of 0.5 moles per liter HCl. Now, this is our original solution, okay? Then we added water to make the new volume 100 mils, okay? This is our new or our diluted solution. Now, super important here, the number of moles does not change, okay? N stays exactly the same because we did not add any more acid or take out any acid, okay? So N stays exactly the same. Okay, so that means we have two formulas here. So we got C1V1 equals N. Okay, and this is our original solution. Number 1, original solution. And then we got C2V2 equals N. Remember, N does not change, so it's the same number. And 2 means this is our new solution or our diluted solution. All right, move my last bit of sticky. And let's look at an example. So when we put this together, we know N is the same number, so we can write this as C1V1 equals C2V2. Put our numbers in from up here. 0.50 moles per liter is concentration from our original solution. And remember, we've got to put our milliliters into liters, so 0.0250, that's in liters, that's our volume. Now, we don't know our new concentration yet, but we do know the new volume, 0.100. Again, that's in liters. Okay, let's rearrange this. So we end up with 0.50 times 0.250, all divided by 0.100. And that's going to give us our second concentration, or our new concentration. And here is the answer there. Now remember, at the end, always check your significant figures. So our final answer is 0.13 moles per liter. I hope this was helpful. I'm going to post a picture of my notes here for you guys as well. These were the two topics that Class 1-1 really wanted to review. So I wanted to review them for you guys as well. All right, good luck with your study for the exam. Yay!